Section 30 of The Science History of the Universe, Volume 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Science History of the Universe, Volume 2, edited by Francis Rolt Wheeler. Geology. Chapter 15, Descriptive Mineralogy, Part 1. There was a time when there was no life upon the earth, and therefore all matter was mineral. This lifeless period extended through untold ages, during which no organic substances were formed, and indeed could not have lived. When, however, the earth's surface became fit for organic introduction, life appeared, and thenceforward the mineral matter in earth, water, and air began to be acted upon by these new agencies, and the living vegetable and animal forms were produced. Life is continually evolving new forms and substance from apparently lifeless matter, endowing it with properties that in the earlier ages it did not possess, yet all life is based upon the mineral. In addition to the formation of living organisms from matter, it should be noted that these living organisms contain large quantities of such matter, such, for example, as carbonate of lime, the mineral which constitutes the limestones, the chalks, and the marbles, making up the shells of the shellfish and the calcareous covering of the coral polyp. And consequently, just as the animals owe a debt to the rocks, so quite a large portion of the rocks in the earth has been formed from the mineral remains of plants and animals, only again to be recombined into organic life. Thus it may be seen that in the same manner as there is a geographical cycle, there is also a mineralogical cycle, as the coral polyp takes the mineral calcium from the seawater and at death returns it to the mineral kingdom. Man is what he is today, not only because of the cell life of his ancestors, but also because of the mineral characteristics of the substances of which they were originally formed. A mineral has been well defined as a homogeneous substance of definite chemical composition, found ready-made in nature, and not directly a product of the decay or the life of an organism. It is evident from this definition that the term mineral would apply to an enormous variety of substances. However, only those which possess at least a fair economic importance will be treated in the following pages. One of the best known and at the same time one of the most valuable of minerals is the diamond. In regard to this stone, E.S. Dana, in his Minerals and How to Study Them, gives the following description. The diamond is usually found in distinct isolated crystals, most of them very small, but sometimes as large as a robin's egg or even larger. The crystals are commonly octahedrons, though less often some of the other forms of the isometric system are observed. The natural crystals before cutting, rough diamonds they are called, frequently have rounded edges and curved faces, or the faces show little pits. The hardness is higher than that of any other species, and the specific gravity is also high, 3.5. The luster is very brilliant. The brilliancy of the diamond, however, is much greater when cut with many facets than in the natural crystals. The most highly priced stones are colorless, but it sometimes occurs as pale yellow, green, pink, or blue. The diamond consists of pure carbon, and has thus the same composition as a piece of charcoal. Diamonds are used for cutting glass, and in the form of powder in grinding diamonds and other hard gems. The black, coal-like diamonds, set in a collar and rotated rapidly by machinery as a diamond drill, cut quickly through the hardest rocks, leaving a core behind, which is raised at intervals. A well boring is thus easily made. Graphite, or plumbago as it is often called, is usually found in massive forms which may be separated easily into thin leaves or plates, and hence are said to be foliated. Sometimes also it is finely granular and compact. It has the same composition as the diamond, consisting also of nearly pure carbon. It is, however, a different substance in its physical characters and is hence a distinct mineral. Note that they differ in crystalline form. Also, the diamond is hard and heavy, while graphite is soft and light. Graphite is the so-called black lead of the lead pencils, but it is only like lead in its color. It is an excellent lubricator because of its smooth, soapy character when pulverized. Also, mixed with clay, it is used for making crucibles because it is infusible and not affected by the heat of an ordinary furnace. In electroplating, because it is a conductor of electricity. Carbon is also the element which forms the essential part of the different kinds of coal and of mineral oil or petroleum. Anthracite, the coal of eastern Pennsylvania, contains 85 to 95% of carbon and has a bright, shiny surface and conchoidal fracture. It burns with a pale, feeble flame without smoke. Bituminous coal is black to dark brown in color, often dull and with a pitchy luster. It contains less carbon than anthracite, usually 75%, and more hydrogen and oxygen. It burns with a yellow, smoky flame. Brown coal or lignite has a brown color, dull luster, often retains the structure of the original wood, and contains still less carbon, sometimes only 50%. These different kinds of coal and others related to them, though of great economic value, are not properly mineral species, since they have no definite chemical composition. The same remark applies to asphaltum, bitumen, mineral wax, or ozocerite, the many kinds of mineral resins including amber, and finally mineral oil or petroleum, all of which consist chiefly of carbon. Sulfur is another of the chemical elements occurring in nature. It is found in crystals of the orthorhombic system. A common form is an acute rhombic pyramid. It also occurs in masses and in powder. It is soft and, though brittle under the blow of a hammer, is easily cut by the knife. The specific gravity is about 2. It has a resinous luster and a bright sulphur yellow color and streak. The crystals are often clear and transparent. It is used for making sulphur matches. It is one of the 3 substances of which gunpowder is made, with charcoal and niter. It is used in preparing the rubber gum for overshoes and other purposes, also in making sulfuric acid, and in many other ways. Although it cannot be preserved in a mineral cabinet, ice, the solid form of water, is as truly a mineral as diamond or quartz. It occurs in crystalline forms of the hexagonal type, often of great complexity and beauty, as seen in snow crystals. The ice grains that make the pellets of hail, not infrequently occurring with summer thunderstorms, are also occasionally in clusters of crystals, somewhat resembling the hexagonal pyramids of quartz, though this is the exception. Generally, there is simply a concentric concretionary structure. The ice of the pools and ponds is always crystalline, though it is usually only in the first stages of the process of freezing that the crystals are separately visible. Arsenic is found occasionally as a mineral and then called native arsenic. It has a metallic luster and tin-white color, but soon tarnishes on the surface to a dull dark gray. It is also brittle. It is used with copper and tin to form the alloy called speculum metal, useful for metallic mirrors because of the brilliant surface it takes when polished. The lead employed for making shot contains a small amount of arsenic. The compounds of arsenic find various uses, as pigments, sulfide, as a preservative, a poison for insects, white arsenic and Paris green, also in dyeing and medicine. Antimony, like bismuth, is usually included among the metals, for it has a high metallic luster, although its structure is crystalline and it is quite brittle. It is a very easily fusible metal and is useful in the arts because of the alloys which it forms with lead and tin, to which it imparts greater hardness and durability. Native antimony is a bright tin-white mineral with metallic luster, and commonly showing brilliant cleavage surfaces. Bismuth is silver-white in color with a reddish tinge and has a bright metallic luster. It is rather brittle and shows a crystalline structure with perfect cleavages. It is, however, nearer to the true metals than either arsenic or antimony. Native bismuth is a rare mineral. Some of its alloys have the curious property of contracting instead of expanding with heat. Bismuth is also employed in medicine in the form of the subnitrate. Another compound is used as a cosmetic. Other uses are in calico printing and to give luster to porcelain. Molybdenite is the sulfide of the rare element molybdenum. Like graphite, which it much resembles, it occurs in foliated masses or in crystalline plates having a hexagonal outline, rarely in distinct hexagonal crystals. It is also very soft, with a soapy feel, and leaves a trace on paper. Gold is the most highly prized of the metals, valued because it serves as the money of all civilized people, and because of its use for ornaments. It is sometimes found in isometric crystals, as in octahedrons, but usually in plates or scales or wire-like forms. Also in larger masses, called nuggets. It is soft and can be cut by the knife. It is highly malleable and ductile, and especially remarkable because it can be hammered out into very thin sheets. The skillful gold beater can make the plates so thin as to transmit a faint greenish light. Gold occurs mostly in veins in the older crystalline rocks, especially associated with quartz. Gold quartz is quartz, often milky, which either shows little particles of gold scattered through it, or from which gold can be obtained, even if not visible to the eye, after the rock is crushed to powder and then washed to remove the lighter material. A large part of the gold of the world has been obtained from the sands and gravels produced by the disintegration of gold-bearing rocks. These gravels in the bed of a stream may be washed by the miner in his pan, or on a large scale, where a powerful stream of water is thrown against the gravel bank, carrying away the lighter rock and leaving the heavy gold particles behind, usually in the form of little flattened scales. Platinum is reckoned among the nobler metals with gold, and like it is not attacked by any of the single acids. It has a rather dull gray color and is not a beautiful metal, although now more highly valued because of its practical uses than any of the metals except gold. It is rarely found in isometric crystals, as in cubes, more commonly in scales or in larger masses, up to 20 pounds, called nuggets, washed out of the gold sand. The fact that it is fused with great difficulty and is not attacked by ordinary chemical reagents makes it very valuable both to the chemist in the laboratory and in the chemical manufactories, where crucibles and dishes are made of it. It is also largely used by dentists. It has come into use of recent years for the attachments to the ends of the carbon wire in the incandescent electric lamp. Silver is one of the precious metals, useful alike as money, for ornaments of many kinds, and for utensils. The color is a fine silver white when perfectly fresh, but it is easily tarnished, and the presence of sulfur in the atmosphere soon turns it black. Native silver is not an uncommon mineral, although the world's supply of the metal comes chiefly from its ores. It is like gold in its occurrence, sometimes, though rarely, in distinct isometric crystals, more frequently in arborescent or branching groups, in plates and scales or wire-like forms, sometimes in fine threads. It is highly malleable and ductile, and it is the best known conductor for both heat and electricity. Mercury is a remarkable metal because it is a liquid at all ordinary temperatures, only freezing or becoming solid at -40 degrees. It has a silver-white color and brilliant metallic luster, and is so mobile that from early times it has been called quicksilver. Its density is high, 13.6, or higher than silver, 10.6, and lead, 11.4, and for this reason and because of its liquid form it is of great value for scientific purposes. It is used in most thermometers and barometers, and is employed in many experiments in the physical and chemical laboratories. It also has the property of forming a pasty mass or amalgam with some of the other metals, as gold and silver, also copper, zinc, tin, etc., but not iron, and is hence of great value in separating them from the rock in which they occur. Ordinary mirrors are made of glass backed with an amalgam of mercury and tin. Mercury in various forms is also used in medicine, but in minute doses, for it is an active poison. Corrosive sublimate is a chloride of mercury. Native mercury is a rare mineral in nature, though occasionally found in minute globules scattered through the rock. The common ore is cinnabar, the sulfide of mercury, sometimes called natural vermilion, which is found in masses of a fine red color, and sometimes also in small rhombohedral or prismatic crystals. The luster is adamantine, and the color bright cochineal red, sometimes becoming dull and dark. The streak is scarlet. Crystals are usually perfectly transparent. Copper is one of the most useful of the metals, having been employed for utensils and in other forms, both as a metal and in different alloys since very early times. Of recent years its use has been increased very largely because of its good conductivity for electricity. It thus forms the material of the wires of the dynamo machines, those by which the electrical current is carried for the electric light, the trolley, etc. Copper is also extensively used for electroplating, as in making stereotype plates. It forms further a large number of useful alloys, of which brass, an alloy of copper and zinc in the ratio of about 2:1, is the best known. In the various kinds of bronze, bell metal, gun metal, antique and metal bronze, etc., copper is also the prominent metal, alloyed with tin. In aluminium bronze it is alloyed with aluminium. In German silver it is alloyed with zinc and nickel. Copper is obtained in nature in the native state, and also from a variety of valuable ores, which are some of the most interesting and beautiful minerals. Fool's gold, chalcopyrite or copper pyrites, is the beautiful deep brass yellow copper mineral often called yellow copper ore. The color is so golden that it is not infrequently mistaken for gold, especially when scattered in small particles through a mass of quartz. Malachite, the carbonate of copper, is a bright green mineral, often found with native copper, cuprite, and other copper ores because of the readiness with which they are converted into the carbonate by the action of the carbon dioxide present in the air or dissolved in the water. When close and compact, it can be cut and polished, and thus forms a handsome ornamental stone. Azurite, or the blue carbonate of copper, is not so common as malachite, but it is also a beautiful mineral, and when in large transparent crystals of a fine deep blue, it forms one of the most attractive specimens in a cabinet. The crystals are oblique rhombic prisms. Lead is one of the most important of the metals, and even pure is used for many purposes familiar to all, as for pipes to convey water and for shot and rifle balls. It has a dull blue-gray color. It is very soft and malleable. It is often alloyed with other metals, thus with tin in common solder and pewter, with antimony in type metal, with arsenic in small amount for making shot. White lead, the carbonate, is largely used in making paint, also the oxide, red lead. The supply of the metal, which is used so largely, is obtained from its ores, especially the sulfide, galena. The latter is one of the commonest of minerals, occurring in large deposits in many mining regions. It is also used for glazing common stoneware, and hence it is called potter's ore. Tin, one of the most important of metals for a great variety of technical purposes, occurs, if at all, only very rarely in nature in the native metallic state. The supply is obtained almost solely from a single ore, the mineral cassiterite or tin stone. The use of tin that first suggests itself is for tin plate, so largely employed for vessels, roofing, etc. This is simply sheet metal coated with metallic tin. Tin enters into many alloys, as the various forms of bronze, gun metal and bell metal, etc., in which it is alloyed with copper. It also forms alloys with lead in pewter and several kinds of solder, with antimony in Britannia metal, with both lead and antimony in Queen's metal, and copper and antimony in Babbitt metal, with lead and bismuth in fusible metal. Cassiterite or tin stone occurs when crystallized in square prisms and pyramids and other related forms. Twin crystals are common. The crystals have a splendid adamantine luster and a brown color, sometimes nearly black. Iron may well be called the most important of all the metals. How large a place it takes in the work of the world is shown by the fact that each year some 50 million tons are produced from its various ores and turned into some of the many forms needed by man. The entire supply of iron which the world uses each year is obtained from its ores, in which the iron is in combination chiefly with oxygen. These ores are the minerals hematite, magnetite, and limonite. Siderite, the carbonate of iron, is also an important ore. The meteorites which occasionally fall to the earth often consist entirely of metallic iron. Magnetite suggests in its name its most striking character, that of being magnetic. All kinds are strongly attracted by a magnet, and one variety, called the lodestone, found for example at Magnet Cove, Arkansas, is a powerful magnet itself. It has a north and south pole, the power of picking up particles of iron or steel, as tacks, and also, when suspended, it sets with its poles north and south like a compass needle. End of section 30.